Harold has anybody he might want to do on Saturday, but you might ask.
Yeah, we'll find out.
Okay.
All right. Well, welcome everybody. It's July 28th. Time for our weekly Robot Club meeting for the Dallas Personal Robotics Group. We have people from all over the United States and all over the country, and we like to sit and talk about projects we've been working on and challenges we've conquered and challenges we want help with. So a lot of great experience in the club, and welcome to new visitors and old members alike. No jokes on the old comments here, but myself included. Anyhow, with that, I would suggest I'm going to just kind of bow out of the conversation after a little bit, but if we could just go around the table and figure out what's been going on with everyone this week, then that'll be great. Anybody want to jump in and show their latest conquering of the robotic wizardry?
I'm new, so I can be first real quick.
There you go. Welcome.
I have a Raspberry Pi, which I just loaded per instructions, and that's where I'm at.
That's the first step.
Yep.
What are you going to do with it?
Well, I have some plans. I have a couple of things I want to do. I have something called HARP and something called CARP that I want to build. The HARP is a home assistant robot personality, AI-based, meandering around the house, maybe security, maybe an Alexa clone type thing. And the other one is CARP, which is a car-assisted robot personality. And that's going to be working in the car, maybe acting as a car alarm later, maybe giving some sort of a AI type interface to work with the car and make things easier. So that's my grandiose plans, and I'm at a beginner level, so I'll probably come up with some questions later.
That's pretty awesome. Aim for the stars, man. That's great. What do you think? Maybe next year we'll knock out Alexa and Google Home?
Could be.
Yeah.
I've been mildly interested in AI and also robotics for quite some time, but I've just never gotten around to doing anything. But now that I'm mostly retired, I have time to play.
Well, you got company on that topic here. What's your background?
I'm a web programmer, VB.net, VB ASPX.
Okay, excellent. So hardware is kind of interesting then.
Yes.
Well, that's good.
Soldering the other day on my, this is a Wilderness Labs Micro F7.
Yeah.
And I turned these things on and I plugged it in, but it did not do what they said it would do. So I'm kind of stuck with that. That's a microcontroller board. It's supposed to run .NET. Similar
cool.
to Arduino, supposedly.
You got guys in the club with experience from embedded to web to little server stuff to all kinds of different languages and mechatronics and motors and big stuff and little stuff and semiconductors, and yeah, so there's quite a smattering here to lean on.
Yeah, I actually listened to your YouTube video from last week, so I was quite impressed by everybody's knowledge. One quick question before I let somebody else go on. I don't want to eat up all the time. I was wondering how long those drive motors really last in robots. You see some of these motors aren't very big, and I think they probably wear out after a month or year. What do you think?
No.
Well, I could possibly jump in. It has a lot to do. Motors have a lifespan that's quite influenced by their stress level. So a motor that's well taken care of and doesn't get stressed out can last a long time, as long as it's got a little bit of lubricant in the gears. But if the motor is getting stressed out, like it hits stall current, what you're doing is heating up the inside of the motor, and you're heating up the coils of wire in the motor and breaking down the insulation barriers between the wires. And that's the kind of thing, in addition to, if it's a brushed motor, there will be sparks and things that'll cause carbon to build up on the brushes. So it's that kind of thing that causes motors to get old. So if you're basically designing a robot and you figure out how much the robot's going to weigh and how big the motors need to be, if you over-engineer those motors, you won't be stressing them out. And you can also design into your robot whether or not the motors are taking up too much energy. So if they hit stall current at, let's say, 3 amps, you could have a sensor on that to say if the robot ever takes, gets anywhere near 90% of that, you might want to back off on powering the motors. But basically, the motor life has a lot to do with how much stress you're putting on them. Otherwise, they should last quite a long time.
Okay, cool.
Mm-hmm. Yeah, I don't know that anybody's ever burnt out a motor that I've known of in the club. Does anybody?
Not from normal use.
I will say
Yeah.
those small motors, like some of the less expensive robot kits. There's one with a right angle drive. They're yellow. They're quite popular. They're real. If you've got one of them, you can hardly stand to be in the same room with it when they're running around. They're so noisy. And they're sort of inexpensively built, and they break pretty easily.
That's what puppy's like. He's battery died. I thought about replacing it, but he's just way too noisy. It's an app-controlled robot my dog hates.
I would say, I don't know if you can see these. The motors I've used for many years are these Pitman motors. This is just one I just grabbed off the shelf. They have a built-in coder, and they have a gear head on them. And I've got robots. I've got one back here behind me that I built in 2008. So it's been running 12 years pretty intensely. I will say this. When I buy these motors, I always like to buy several of them. For one thing, we get them surplus, and so they're not likely to come around again. But that way I have some pieces. And there was one case in which I broke one of the gears in the gear head, and I had to pull one of my spares out in order to repair it. Now, this is for a robot that runs outside and takes pretty intense beating. For the ones that I've run inside, I don't think these are motors that started off their life, I think, in Xerox machines. And there used to be a whole bunch of them on the surplus market. If you could pick any of those up, like if you had, suppose there was a store named Tanner's that held old surplus electronics, you could buy up whatever they had. But I've not really had trouble with these nice industrial motors. Quite robust.
Yeah, and I'll kind of follow on with that. That's for a fairly sizable robot, but if you're building small robots like the little Zumo, like 100 millimeter square robots, there's a company called Pololu. I think they're in Nevada, and they make these tiny little motors. You can see this is a mecanum wheel and a big brass hub, but the actual motor is just that part on the end. And Pololu put out several dozen varieties of these motors. They're all the same size, and they have metal gears. They're called micro metal gear motors, and they have all different gear ratios and power requirements, different levels of strength, torque, I should say. And they also have 3 different kind of encoders that you can get on the end for basically measuring how far the motors have gone for doing odometry. And so these are metal gear motors, and when you mount them with a little plastic box over top of the gearbox, that it's like a $3, I think, for a pair of these mounts. These little metal gear motors you'll find in a lot of small robots, and they're a lot better than the yellow plastic ones that David was talking about, which use plastic gears. These are pretty noisy, and depending on the gear ratio, they can have quite a lot of torque for a small robot. For 4 of these motors on a robot will drive a pretty small robot up a hill and everything. So I can highly recommend the Pololu micro metal gear motors.
Okay. I was actually thinking I might buy some base unit already made. Like I've seen, well, that's not the one. I'm off looking at my other screen, and I don't see it on my thing right now. But there's like a DF robot or something like that. It's got several pretty substantial looking units. I'm thinking of a robot like R2D2 sized.
Oh.
And I'm trying to decide if wheel motor or geared treads is a better option for running around the house. I'm worried about marking wood floors. I'm thinking probably wheels.
So whatever you do, make sure you get motors with encoders. And
Yes.
Yes.
plenty of good arguments on this call for that.
Encoder is the thing that tells you how far it's gone. Is that what an encoder does?
Yeah.
Like,
It's gone, but it's a way to give feedback from the motor it's a way for the motor to give feedback to the controller on what it's currently doing, and from that what it's currently doing, you can infer how far things go or how fast the motor's running and all that sort of stuff. Without those, you just turn it on and you have there's no way for you to know. There's no way for your robot to know how fast it's going or slow it's going or those sorts of things, as well as how far did it actually turn. You know,
Well,
you
and-
know all those things.
I wondered how you figured it out.
Yeah.
And the encoders are usually on the motor shaft itself, which means that if you've got a gear ratio of, let's say, 100-to-1, that motor shaft is spinning 100 times every time your wheel goes around once. So you actually get quite a lot of accuracy off these encoders. And there's two kinds. There's ones that use an optical interrupter, and as the motor spins, it's basically interrupting a light beam. And the other ones, which have a little magnet on the end like these, use what's called a Hall effect, which basically measures it creates a square wave of that magnet spinning around, and you can then count the pulses of the square wave.
Detects the changes
But
in the magnetic field.
you could measure off the wheel rotation itself, but you get a lot better accuracy if you use an encoder on the motor. And a lot of these robot motors have encoder kits that go with them or already have encoders on them.
Cool.
Let's just follow on to that. This is the Pitman motor I was showing earlier. See that? There's a glass wheel with a bunch of, can't see it?
I see it.
We see it.
And it's got a couple of optical encoders on it. So it's a quadrature encoder. That is, the two signals are 9 degrees out of phase, so you can tell not only how fast the motor is spinning, but in which direction. I can tell you from my own experience that you actually don't need to know the direction because you're telling the motor which direction. You can actually use the command. I mean, you get 99% of the way there with the command. But
Right.
these are quite common. Motors with a gear head on one end and an optical encoder on the back. They're very common, and they solve two hard problems for you that are easier to buy. We've made homemade encoders. They're not that hard to make. These things are very robust. I think this one gives me 512 interrupts per revolution. And the gear head on this is about 40-to-1. And that comes out to, thousandths of an inch per tick. It's better too many ticks than not enough.
Yeah.
Well, cool. I'll let somebody else go. I don't want to eat up all the time. I can ask more questions later.
Well, you've come upon a topic that we all kind of like to talk about. And David here was talking about that as an odometry expert. He's done some pretty amazing stuff where he can, just with odometry, move a robot forward, go around, and come back to exactly the same place it started, just with particular motors.
Yeah.
And he's got some videos online if you go look for them.
Okay.
I only object to the word expert.
Well, anyway, if you search for David Anderson is who's talking, and he's got some robots on his website, and there's some videos. He goes up in the mountains with his robots and drives around and comes back to the same location, even going over bush and stuff. So,
That brings me to my contribution to the evening, if I may. Okay, these are the battery packs that I've been using on the outdoor robots. These are sub-C cells, 10 sub-C cells, so that's a 12-volt pack, and I take 2 of these to drive the robot, so I get 24 volts.
Did I hear you correctly? Those are just D batteries?
Sub-C size batteries. These are nickel metal hydride. And anyway, so I had to replace them. I was upgrading them to that robot. I had to replace them. And I spent a whole lot of time thinking about it. And really, probably the optimal solution is to go with Wi-Fi, like I do on behind me helicopters on the ceiling up there. They're lightweight. They're incredibly powerful, and you can weld with these things. And and they're not that expensive. There you go, just like that. The whole problem is that the charging regimen is very complex, and if it's not religiously adhered to, they sometimes spontaneously burst into flames and melt your robot. And if you want more pictures of that, I've got pictures on my webpage. So that's bad. And in this particular robot, the only other robots I use, I can remove the batteries when I charge them. But this particular robot, the battery screwed down inside where you can't get to them. And so after much soul searching, I decided that I would go with the nickel metal hydride. They're heavier. And while normally that's a disadvantage on robots, it's actually an advantage. It has some weight. Your traction goes up as the weight of the robot goes up. Not too much, but so for both those. So I've spent the last week. Can you see this?
Yeah.
Yeah.
Yeah,
This is the bottom. That's the bottom plate of the J-Bot off-road robot. As you can see, it has attached to it 2 brand new tin cell packs. And ready to be installed. It takes, I think it's 40 screws to get the whole thing back together, with all those little holes are. So I've been postponing doing that. I finally got it back together the day before yesterday, and I had 0 voltage. So I removed those 40 screws apart and found the connector that I had drawn incorrectly, and repaired it and tested the whole thing, put it all back. So this is ready to go. As you can see, they're just held in the paper here, but it's pretty robust. And so that's my progress for the day. I've got battery power.
Okay. So do you have the robot itself so you can show it up to him, since I know what you're talking about, but he probably doesn't.
It's all apart. Let me see if I can carry it over here. Hang on.
Okay. Because, yeah, it's pretty neat. Now, the one thing you might have a problem with is when it bumps into a wall or something, it may lose track on the count. So he has a couple other sensors in it when he shows it to you that takes it into account. So you'll eventually have to have other sensors besides the encoders for that reason. But here's, it's a big one.
Can you see that at all?
Yes.
This is the one that goes up in the mountains.
This is where the bottom plate is missing and the batteries go on either side there. I don't know if I can turn it over without things falling off.
I have a lousy connection today.
Oh, so far so good. And let's see, you can see a couple of those Pitman motors. There's one mounted. I don't know if I'm holding it right.
Yeah.
No, it's good.
And
That's his big one. Do you have your small? Dave? Do you have your small round one? That's probably the. Yeah, grab that one and show it to him, because that's the size he's thinking of more for indoors. Right? You were thinking more indoors, or are you thinking outdoors?
I'm thinking indoors at this point, because it's going to be a home security robot.
Right.
Around.
Yeah, he has one that's a round one, and you will tend to actually want to probably round for 2-wheel indoors. That seems to be the norm. Yeah, like that one there.
Differential steer.
And I just posted David's webpage about his robots.
That's good.
You posted that on the main website, or
on the chat, probably.
There's a little icon up there. You can see the chat going on the right-hand side of your screen.
I've seen it bouncing around. Oh, there it is.
I feel like Vanna White.
Yeah, you just need to turn the just need to turn the letters now.
I was thinking Vanna myself, actually.
Thanks. I thought I was going to have to do that.
Somewhere in all that, I'm off my glass. There you are. I think that's all I have to report.
All right, well, I guess I can kind of jump in then because I haven't got a lot to report in terms of progress. As some of you know, I've had I've got a Raspberry Pi based robot, and I had built my whole front sensor array of bumpers and analog infrared sensors into a single unit that would then send all of its messages to a small microcontroller called an Itsy Bitsy. And I was using the Itsy Bitsy as a slave and the Raspberry Pi as a master, and basically communicating between them. And I've had all sorts of problems with that. It's not been easy getting the Itsy Bitsy and the Raspberry Pi to communicate reliably. I did all the hardware over, and it's quite nice now that the hardware is all solid. I've got in the very top corner there, I'm not sure if you can see, there's the Itsy Bitsy. And it's actually on it's on its own soldered breadboard and stuff like that, and it hardware-wise is reliable, but I've not been able to get the software to work properly. And just about the time that I was doing that, I got a notice from Pimoroni, which is a company in England that does a lot of the robotic stuff, and also like kind of kids education, and they do more than just robots. I'm going to try to share my screen. A window actually, and I click on a window. Here we are. So this is a new breakout garden device. I'm not sure, is it coming up yet? Oh, there. Okay. So, can you guys see that?
IO expanding.
Yeah.
Yeah, okay. There's a series of devices called the breakout garden, and there's a whole bunch of them. Most of them are sensors. And these are I2C basis connections, and as well as SPI, but mostly I2Cs, which means they just have power and then two wires. They use an interrupt wire on some, but I've never seen that used. So it's really just power and two wires as a bus, and you can connect all these little devices. Let's see if I can get that to pop up. So this is, I can get that to go. Come on, here we go. So there's lots and lots of these. There's dozens of them. Some of them are displays. This one is a time of flight, which a sensor which has a little laser. It can measure to about 1 inch accuracy up to 4 meters in distance. Pardon me for the metric imperial screw up there. There's displays, all sorts of stuff. Now, they've just announced this new one. It's called the IO Expander Breakout. And this has a little, they haven't shown a photo of the back of it, but it's got a little microprocessor on it called a Nuvoton MS51. And it's got 12-bit analog digital converter on it. And this device has, 14 pins that can be used for PMW and analog inputs. And it's programmable. There's a huge technical reference manual that goes with this processor. And I've been corresponding in email with one of the tech people at Pimoroni about this, and I'm going to order one. This effectively does what my Itsy Bitsy does, which is it acts as an input device with its own microcontroller that you communicate with over I2C. So if I can't get this Itsy Bitsy to go, and there's a philosophical argument whether you just keep banging your head against a wall or not, but if I can't get it to go, even though I want it to go, I might try this. It's only 7 pounds. It's like, $15 or whatever. And it would give me an easier solution than my Itsy Bitsy, although I'm quite affectionate with the Itsy Bitsy. I like it as a processor. It's like an Arduino. And you can program it with the Arduino IDE. So it's a C# programming environment as opposed to the Raspberry Pi where you can program anything. I'm in Python. This, on the other hand, would take me out of having any kind of extra programming, and I can just use it effectively as an input device for all my front sensors. And since I've got 5 analog infrared sensors in the front, that would give me my analog, and then the other pins I can use for the digital for the bumpers. So this would basically solve my front sensor problems for 7 pounds 20. But there is the philosophical angle on do it yourself or just buy something that solves the problem. But I don't know. Kind of up in the air about that at this point. I see David smiling because he knows the battle I'm in the middle of. But anyway, that's kind of what I've been doing. And I think I reported last week that one of the local girls, a 10-year-old girl, I had gone ahead and helped her and her dad decide on a robot. And they bought a WaveShare Alphabot 2, which is a little 110 millimeters round robot with 2 circuit boards. Uses those micro metal gear motors. Highly recommended robot. Very nice little robot. It's got infrared, ultrasonics. Doesn't have encoders on the wheels though. It's the one downside. But it's a nice robot. And I heard from her dad that she had kind of played with a little bit, and then now she's playing with her sister. So it doesn't sound like she's doing much with it, because I think it's that I haven't had a chance to go over to their house again since we set up the robot. But my impression is that she probably, as a 10-year-old girl with a dad who's not technical, doesn't know what to do next. So I'll probably have to go over and maybe give her some programming challenges or something like that to say, make the robot move forward. And, it's got ultrasonic and infrared sensors on the front, so it could avoid objects. So the idea would be, even in MakeCode, which is a graphical environment, it's perfectly possible for a 10-year-old girl to program if she has a goal, but I think she doesn't really know what the goals might even be. So I think a little guidance is going to be necessary to get her going. But she apparently loves her robot, though, having a robot. She doesn't know what quite to do with it, but that's kind of my problem too. So.
Ray, this little board here, 720 seems pretty high just for a little piece of board with a couple of pins on it. You say there's a processor on the other side that we can't see?
Yeah, it's a Nuvoton MS51, and it's actually, I've in my correspondence with Pimoroni, I've asked them to update this web page, and they've added a link to this technical reference manual, which is a huge PDF. It's like, how big is this thing? It's 319 pages long, so it's a full-on microprocessor, which I think in itself is pretty cool. You can actually, if you're willing to reprogram the board, you can use it as a slave processor, without, and the libraries, of course, are all open source. So if you're willing to program in Python, you're kind of given an environment, a little board with a cool little microprocessor, and I can't remember the speed of it. It's they said it was I think it's 12 megahertz. I can't remember, but it's a relatively powerful microprocessor.
Your plan is not to program it, so rather just use it as basically an interface on everything, right?
Yes.
So you're just going to basically read those pins.
Yes.
It's not the I2C trans they give you.
Yeah, there's a Python library, and you just read right off the pins. You can program the pins to either be analog or PMW. There's the 6 pins that are PMW. There's the 8 that are analog, and then any of them can be standard GPIO. So, it's the Python library. I've looked through it. It's relatively straightforward. You're just reading pins. Yeah, it's really simple, easy to use.
So if you're reprogramming what the pins can do, telling it you're an A to D input, you're a PWM input,
right,
then you are having to program the board in some way.
Well, you're configuring it.
And so they give you libraries to do all those things?
Yep. Yeah, there's a link to the Python libraries, and all you're doing is basically, just like any of these sensors, is you just set a pin to be analog or PMW, and it kind of, they take a lot of the pain away on that kind of thing. You're really just doing configuration, and if you're already programming in Python, it's an easy one.
When you talk to the thing, does it send you back the total of all pins in one block, or do you request individual pins?
Individual pins. And in my email, I can't remember, the woman that I was communicating with, she said that it can operate, what was it? I can't remember the speed, but it's pretty fast. It's faster than 20 milliseconds, which is my loop, so it shouldn't be a problem in terms of performance. It's a fairly capable little processor. I looked up the actual processor, and it's pretty good. I mean, you could, in David's world, you could run a whole robot off that, couldn't you?
Yeah, enough pins.
Yeah. So anyway, that's it for me. That's about as much news as I can think of from New Zealand. So I'll pass it on to someone else. Actually, Jack, what were you up to last time you kind of jumped into the fray?
Yeah, so I was just fixing up some of the glitches with the competition robot. Well, actually, it was fully stuck, and I couldn't figure out what was going on. But I finally figured out there was this one pin that controlled the motor on the LiDAR sensor, and it was disconnecting and connecting. So that was then triggering the servos somehow to glitch up.
Yeah.
And so all I needed to do is fix that one pin, and a lot of it was fixed.
You mean it was a connector all along?
What?
It actually was a connector all along?
Yeah, it was. I've actually got a video of it working. I'm trying to pull it up. But it's working pretty well now. Just need a better gripper, which I'm printing out right now.
So you did a better solder on it then? Or?
Yeah, yeah.
Yep, connectors and God, what's the other thing? Oh, and switches to the least reliable things in the electronic circuit. So.
Power and cost. All problems are caused by power and cost.
I couldn't hear that. All right, here we go. I've got a video that I can show you real quick.
Okay. So, are you presenting? There we go.
There we go. All right, can you guys see that?
Yes.
Yeah.
All right. Oops. Oh, there we go.
Wait a minute, I think you got the can, not the robot there.
Well, that's the thing. I need a better gripper, and the lighting was really bad in there, so the camera didn't work that well. But aside from that, it does it all right. And the carpet was slowing it down too much. That was another problem.
Yeah.
But
What's that thing that sticks up in the air?
that's the little switch thing to make sure that it hit the goal. I don't want it up all the time so that it doesn't get in the way of the LiDAR scanner.
Jeff, are you reading your motors with encoders, with wheel encoders, or
honestly, I'm not using encoders on this one. It's just relying on the LiDAR sensor to know its angle and distance.
I was thinking more of the encoders in terms of PID controller, so that you can have velocity on carpet and hard surfaces and so forth.
Yeah, I probably will do that. Doesn't.
I mean, that's actually one of the problems that PID solves.
What?
That's one of the problems that PID solves.
Okay. Yeah.
Being able to have. It also helps with things like your turns become more definable.
Okay.
And so forth.
So Jack, from this video, I get the feeling that you're just teasing your robot.
You know they're gonna come get you. The robot overlords, they hate that.
Yep, someday.
It'll wait until you're asleep. Yeah.
So.
Jack, is there
What?
Do you have some kind of sensor on the tail wheel?
No, I don't. Why?
I was just curious. I thought I saw a wire or a light or something back there.
Oh, that's probably the Mega. I've got 2 Arduinos on this one.
So does he think?
Oh, sorry, David.
He thinks he has it. I see the
Yeah.
gripper clip. Okay.
Yeah, he thinks he's got it.
And then he puts up the little flag there to.
Yeah.
Catch the
Once
goal.
he knows that the flag won't interfere with the LiDAR sensor. I'll fast forward a bit.
How does it know to pull the flag down? Is there a switch up there?
Well, just along the steps, it knows when it needs to come up and when it needs to go down. So, like, once it reaches there, it knows that it's not going to turn enough to where the LiDAR sensor is going to interfere with the point where it's looking at. Oh, there, I had a little bit of a problem. But And then there's my little light show at the end of it. Once it collects all 6 glass or cans.
Celebratory light show, huh?
Mm-hmm.
So,
So
are
Jack-
you going to have music playing when it hits the goal too?
No, I'm not. But that would be a good idea.
Have music and lights.
Mm-hmm.
So Jack, you've got 2
You have it,
Arduinos
you know,
in there. What's
a
the
little.
main processor that's running the robot?
What?
What's the main processor on the robot?
Well, the Mega the whole time is watching the LiDAR sensor and is controlling the lights. And then I guess the main thing would be the Uno, which controls the motors and the camera and everything else.
Oh, okay.
Mm-hmm.
Cool. So it's kind of a cooperative venture on the part of
Yeah.
the operators.
Yeah. Mm-hmm. So finally, it's working.
Excellent.
Yeah, it looks good.
Thank you. Hopefully, we'll be able to have the competition in November.
Time will tell.
Mm-hmm.
We may have to have an outdoor version where
Yeah.
things are going.
Yeah.
I'm thinking.
The very first DPRG competition I ever entered, which was back in the 90s, and I was telling the judges that after my robot completed its mission, that it would spin around in a circle and then it would play Karl-Heinz Stockhausen's Gesang der Jünglinge.
Wow.
And there's like maybe 60 people in the room, and one guy in the back of the hall just fell off his chair. I never knew who it was. Of course, I didn't do Gesang der Jünglinge, it just made little beepy sounds, but fair enough.
That's not the one with the helicopters, is it?
At that time, I was told that we would get extra points for entertainment value. I think that's been since dropped, but I would recommend that we think about doing that again. That light show, I mean, definitely for the light show.
Yeah.
Wait, so what is that
robot
song?
Torquing, you know?
Well, Stockhausen was kind of an amazing innovator. One of his, I can't think of the name of the piece of music, but he composed it so that it would be played on, I think it was 4 helicopters. Yeah, he did all sorts of really bizarre stuff. I saw, or I guess listened to one of his concerts in London, and they had basically had, I think it was 6 speakers. No, more than that. There was both verticals, and so it was 2, 8, 12 speakers around the auditorium, and it had sounds. I wouldn't call this exactly music in the traditional sense, but it had sounds that would go from the floor to the ceiling diagonally across the hall, and all these things would swirl around, and if you closed your eyes, it felt like it was in your head. And he's considered quite an innovator. I think he died about 5 or 10 years ago, but he's a pretty amazing guy. So the idea that a robot would play Stockhausen, that's great.
Perfect, isn't it?
It's perfect. In any case, so
with 1 bit. You know?
yeah, with 1 bit Stockhausen.
1 bit.
Yeah. So how's your lawnmower going, Ray?
It's going pretty good. I got, I don't have it here. It's actually in the garage. The linear actuator seemed to work pretty good. I was kind of wrestling with, you know, how to get everything fastened together, and bought a bunch of lock nuts, but lock nuts can, you know, especially if you know, have a threaded rod that has a little burr on the end, and it chews out the little nylon part. It's not much of a lock nut after that. So got out my MIG welder and just, you know, tacked everything together so it can't, you know, it can't come apart. So it it seems to be working pretty good, you know, just for something that's, you know, it's kind of cobbed together.
Yeah, picture, Ray, do you have a picture?
I got the. Say that
Do you have
again?
a picture? Do you have a picture?
No, it's out in the garage. I didn't bring it in before I got on the call. This came from Banggood. I actually ordered this. It's a stereo camera. February 2nd, and it showed up here a little while ago. I also got some cameras for it, some wide-angle cameras. So, and they're kind of on a longer. I don't know if you can see it in there. Probably should take it out. A longer connector, so that it can stick out quite a bit above it. That's the. I guess I got to get it in front of the camera. That's the wide-angle camera with a much longer connector tail. So it would, you can twist them around and do weird things with them if you want to, as opposed to them being, connected like right there where the other camera is. But it was really cheap. It was like less than $14 US. And, but I think you get what you pay for, and the serious lack of any kind of documentation that's not in Chinese. So I did find some C routines that it looks like the guy from OpenMV actually did in 2014. So it's a lot older than I thought it was. And I'm not certain at this point. I haven't looked into it enough to figure out if that has to be compiled and run by itself, or is somehow it wouldn't make sense. But I've certainly never done it. Added C routines to something Python, and this is all for the this is the MaxPy dock board. That's the one with the the LCD on the back. So that stereo camera would replace this little black circle here, or connect to the connector that camera connects to in the box. So, and basically updated there was firmware in both this and the OpenMV camera that needed updating, and the IDEs both needed. I had older versions of it, so when I first powered this on, it didn't even work because my firmware was way ahead of the IDE version that I had, so I had to update both. So hopefully I can get it, find enough information to actually compile the C program that he wrote, and it's very long. I was surprised how long it was. It looks like it's over 1,000 lines of code to get it to work. So that was kind of where I'm at. Kind of hoping to get the stereo camera working on the MaxPy. So this little guy. So. Anyway,
cool.
That's all I've been up to.
We need a picture.
You need a picture.
He's greedy.
Okay. I'll maybe I can run out there and grab it and come back here in a minute. But I used
sorry.
Go ahead.
David?
Oh, I was just going to say I could give a long, boring lecture on, odometry or something, and give you a chance to go out and get a picture.
Or you can have the robot play the music. How long is the music?
One bit at a time.
1 bit at a time. Or you can show it next week.
I can go out and get it. It'll take me a couple minutes to go over there and get it, but you should probably let someone else go in the meantime. So,
I kind of like that. It sounds like a country western robot song. 1 bit at a time. 1 bit at a time. Easy.
Yeah, there you go.
Yeah.
That doesn't sound like
it
a
was
song.
one choke over the line, that was. Okay, well, if you want me to go get it, I'll go get it. Like Arnie said, I'll be back.
I'll be back.
Well, in the meantime, I guess I'll make a comment while he's doing that. Since I haven't done any code. I was going to. I started to look for the code for the robot that the other week I had done. So, but I'll show it again since the one guy hadn't seen it. So, here's that robot that.
Oh, John, you froze.
John, just as you were about to say whatever significant thing you were going to say.
It's a conspiracy.
Yep. There's a conspiracy to keep John from talking. I think he may have to log out and log back in again.
I think he probably did what I did a few minutes ago and accidentally hit something and just everything disappeared.
Well, while we're waiting for John to come back, Harold, what are you up to?
Well, I can tell you, I'm up to feeling better about the presentation. I got a workshop kind of thing I got to proctor on Thursday. But I can show you what I've been doing here. Let me OBS it around a bit. All right. You on the Google, you might want to blow me up there, so to speak. I finally got my the motors I got in last week, which I told you, and I got them installed. So I got encoders on everything. New wheels, replacing these sort of thing because, well, this doesn't fit on the shaft. Managed to wire up me some things, and because I've been listening to all of the group, I have since these individual wires, the ones they gave me on this were only about yay long, and I'm like, I've got to run these further than that. So I managed to put them and sheet them up so they're not going to be they're going to be unruly otherwise. I managed to, this is a 3D print off of Thingiverse, and it wasn't really going to work for me because of the clips I had to fit down in these holes way down deep. Weren't going to fit exactly right, so I grabbed it up with some Fusion 360 and I remixed it, and this is what I have now. I gave me 4 mounting holes on the bottom. I cut this out so I could look and see what's going on. It's kind of hard to see, but you can see it's a much smaller hole there. I still have to do a little work. I got to carve some things out to slip my plates on there to grab the electricity, and I put a hole in the back so we could run those wires out. But now if you look how this thing fits together, it's nice and tight. I mean, I could put a little felt on there, a little rubber on there to tighten it up further. And if you look to see how the how those holes are going to line up, see if I can make it.
Yeah, it looks a lot better.
They're going to line up right on top of that thing, man. It's going to, I think it's going to work really well. And when I mount it down hard like that, I know this is raising the weight a little bit higher than I wanted to, but that's going to be down good. And also where your clips go in, I'm in the course of going to put some of. I also started putting some nuts into these holes. I got to do some more shaving on this. This filament wants to spread out a little bit more, so the things don't fit together as nicely as they should. But the idea is I'm going to get a couple of these on here, a couple of this, and this is going to be my back thing. And I got a clip that goes right in there to be able to get at stuff. And I'm going to mount it, I don't know, come up about, I don't know, 2 or 3 centimeters, or just about an inch or so, depending on where you are in the world, and a little over an inch, and then mount all the electronics and bits and that kind of stuff on that. And that's my plan, and get further along with that. I was able to make some pretty decent progress on going that way because, see, me, Azure, and Python have not been good friends the last few weeks. So I'm much better friends with them now, especially after calling for help on, hey, I need help. Oh, there's nothing wrong. Really? Can you show me? I'm going to try to show them. And I'm like, nope, now there's nothing wrong. But for the last 24 hours or so, there's been something wrong. That didn't work what you used to. So somebody did something because I yelled some help and gave them some information. And let's see what else. I'd say that's about it. I've been twitching this up, and I'm used to talking to nobody, but I'm learning to talk to nobody better, I suppose, and showing some of this stuff off. I've gotten a couple of interesting people drop by. There was one, he was a student. He dropped by and he goes, "Hey, you want to see what I've been working on?" And I'm like, "Okay, some drive-by weird link you're about to give me." So I stuck it in the in-private browser, and what this person did was he wrote him a CPU simulator. He built some assembly language for that, so he could work on it, and then built him a bit of a parser so he could write a script to go through. He could write scripts that would generate the assembly code and then run that against his CPU. He was finding like primes and factor. He's doing factorial type stuff on it by putting things around and coding out. I thought that's pretty neat. He said he's a student in college, and he was wondering what I thought about C and other languages, and we had kind of a discussion about that. That was actually kind of neat on the whole thing. Maybe I get to meet some more fun people. Yeah, but anyway, that's.
Harold, I kept meaning to ask you, what's your plan for sensors on this robot? I don't know if you discussed that.
I haven't discussed it a whole lot because I'm still thinking about some of it. I do know that I know I want to put a camera on it, so I've got a swivel, the two servos, 90 degrees or whatever, swivel thing going up here to look around. I'm thinking at the very least, I'm going to put some ultrasonics on the front of it, and possibly, I don't know, do something else on that. I haven't really decided very much on that when I bump into things and that sort of deal. I haven't quite gotten so far, but the end goal is to have the camera with the Latte Panda, so we're using some machine learning on it, and have it recognize faces and recognize things. I'm going to start with kind of faces, that kind of stuff, and have it run around and recognize stuff and categorize people as, I don't know, superheroes and villains. That's the idea. And either that, or this is going to go a long way to running my dogs away from the areas where they like to have accidents on in the room. We could put them, if they see them, it chases them away, kind of stuff, makes loud noises and stuff. But I don't know if I'm going to. That's pretty up there on the thing. But the really thing is to get this where it runs around. You can use a camera and detect things. Maybe get some kind of rangefinder or thing on it where it can do some wall mapping, that sort of thing, so it finds its environment to run around in. But that's about it at the moment. I haven't thought much more past that. It could be. I've got plenty of space to do lots of stuff, so I was going to try to do lots of stuff to play on.
Yeah. One of the things I did a bit of reading into some of the earlier robots from the MIT lab, and they kind of had in what they call behavior-based robots, they kind of set up a whole bunch of different types of levels of sensors. And so at the bottom would be, let's say, a bumper sensor that can tell for survival if the robots hit something. And then it kind of goes out from there. So then you have infrared to go a little bit further and see if you get near something. And then ultrasonics to give even further. And now we got LiDAR for even greater distance.
See, I don't know if you can tell, when I got this, one of the reasons I got this kit was I didn't know what I wanted to do. But you see, I've got nice static bolt patterns here, and already things in the front, and then bolt patterns in the front for doing all those sorts of things you just talked about. And not a whole lot on the side, but on the front and the back, I got tons of those things. So I figured I got a lot of options.
Yeah, cool. Well, thanks for that.
Welcome.
So a couple of you have talked about bumpers. I know Murray's brought it up and Harold's brought it up. I was thinking I would need bumpers on my robot, and I thought that I would just have some sort of metal that could be compressed when it bumped into something, and that would fire off a switch to light up the PIO pin. Is that what y'all are thinking, or did you have something more sophisticated?
Well, I took my inspiration. This is my main robot. I call it the KR01. David's was the SR04, I think. And I kind of modeled my front bumper on David's. He's got one that has a curved bumper. He actually curved the plastic himself. But this is a piece of polycarbonate, 3mm thick polycarbonate. And the whole bumper is actually an aluminum frame, and I've mounted it where there's actually the actual piece of polycarbonate is actually only mounted in one place, and it's a little sprung bolt. So if the robot hits it in the middle, it'll actually bang that. And then there's actually 6 of these little, I don't know if I can turn this around, maybe right there. There's 6 little lever switches. So if the robot gets a left or a right hit or a center hit, it'll hit either the center bumpers or the right or left, or maybe more than that. The idea being is I've got actually, even though there's 6 switches, it's treated as 3 switches. And so if I get a push on this side, I'll get a notice to the robot that I've hit that side, and it can back up appropriately. But this is just a piece of polycarbonate, and it's pretty indestructible stuff. And what I've got is a cutout here, so my infrareds can see through it, because I tried having the infrareds go through the plastic, and they lose a huge amount of range, or they get reflections off the polycarbonate. So I have a cutout here, which in theory, the robot could have something come in there and damage something, but in my environment, inside the house, it's not a problem. And so what I've got is this piece of polycarbonate that's actually only anchored in one place, and it's just a little string on the bottom to hold it in place. And then I've got little tiny bits of sponge rubber on the corners, and that's all that keeps it away from the actual aluminum frame. But that's influenced by David's design. And I think David's robot's like, 20 years old now. So there might be more innovative designs. But in terms of bumpers, that seems to work pretty well. You can also get lever switches that have wires on them. In fact, I even have one. Where'd it go?
Everyone is getting those. If you look at things like in the commercial world, or the stuff that's for sale, like the iRobots, they just got a whole bunch of those little. They got a couple bumpers around the front of them that use a switch just like that when it gets hit. So it works well.
Yeah, if you go to any of the big retailers, like what's the one that does all the thousands and thousands of parts? Anybody?
Mauser, DigiKey.
Mauser and DigiKey. They sell hundreds of these things in different varieties, and this one here has the little wire already attached to it. It's a piece of stainless wire, and I had these on my robot. They weren't meant as bumpers, but they certainly could be bumpers. I was using them as feelers on the top of the robot in case the robot went underneath something and it would hit this and literally stop the robot in its tracks. It was like a emergency because I didn't want to knock off my ultrasonics or something. But you could use these as bumpers, put a couple of those around. They're like $2 or $3. I can't remember how much. But that could be one way to do it as well.
You can stick it on a servo and use it like a blind man stick. Or if you put 2 of them on, it's like a cockroach, the antenna.
Yeah, I like that. There's lots of feet. But there's lots of room to innovate in terms of bumpers. I mean, aluminum. There's a plastic called Delrin, which comes in. It looks like acrylic, but it's almost indestructible. I buy black 3mm Delrin, and that's what most of my robots are built out of. And you almost can't break the stuff. And then you can get clear polycarbonate as well. So you got polycarbonate, Delrin, aluminum, and I've been buying. I've probably spent several $100s in stainless steel nuts and bolts. It's expensive stuff in New Zealand, but. I think I have to agree. One of the things I got off David is that the robot should be somewhat entertaining and also should be aesthetically pleasing, and I like that idea.
I 3D printed my bumper and just 3D printed the springs, and that seemed to hold it all together nicely, but then also impress it the right way.
Have you got any photos of your bumper, Jack?
I'll have to pull some up.
Okay, that'd be cool. Yeah, we could maybe put together some photographs and ideas of bumpers. I forgot your name, Lone Star Miata Club. What was your name?
Doug.
Doug. Hi, Doug. So, yeah, Doug, we could possibly put together some stuff on bumpers.
Don, I would only add to Murray's excellent description that if it slipped past you, that the key information you're getting off of the bumper is, did you hit something on the left or the right? Even if it's just a quarter of an inch off the center line, it would be better to call that left than center if your bumper can make that discrimination. If you hit on the left, obviously you need to turn right. If you hit on the right, obviously you need to turn left. If you hit in the center, it's not so obvious what to do. And there are lots of ways to approach that. But this is a problem with all sensors that are used in pairs, which a lot of our sensors are. That is, sonar, you have a left and a right, or infrared, you have a left and a right. I know what to do when I see a left detection. I know what to do when I see a right detection. What do I do when I see both? What's the proper thing to do? So getting a bumper working helps you start thinking about that problem, thinking about the problem of what to do when you have center detection. And that is really applicable to even the cameras, to all kinds of things. So the idea of pivoting the bumper in the center the way Murray did it pretty much guarantees that once you hit right on that mount point, you're going to get either a left or a right. Which is good.
And in my programming, I've got an if-then-else statement in the Python that basically first checks center, and if center's hit, then I ignore the left and right, because if center hits, generally speaking, it's probably going to also hit left or right because of the mechanics of that particular bumper. But one of the things that David's kind of alluding to in the terms of hitting dead center is that what can happen is if your robot is moving forward and it gets a center hit, it might react to that in a certain way if you program it a certain way, and then it'll come right back and do the same thing, and you end up in kind of a physical loop where the robot will go over and over again, and you have to add a little bit of randomness to this so that it can actually maybe each time it maybe does something a little bit different, so it doesn't get caught into maybe it gets caught between the table and the door or whatever, and just goes back and forth and back and forth. You have to add a little bit of randomness on those center hits so that it doesn't always make the same decision.
Right.
You don't want to keep banging its head on the wall.
Yeah, and since we haven't really talked about it, I'll mention that these are Sharp puts out a whole bunch of different infrared sensors, and this has got a little infrared LED and then an infrared sensor, and they pulse width modulate the signal so that infrared light of other types doesn't influence the sensor, but they come in different ranges and different sizes. And I've even got a big giant one that has a range of I think it's like 10 feet or something like that. This one here is 180 centimeters. So they have quite a different range, and this is an analog sensor, so you get a differing voltage depending on how far away it senses. You can also get real short range runs that are digital, and they just go on or off depending on the range. But they're not expensive, and they're easy to integrate to. You just have them go into your Raspberry Pi on a GPIO pin, and you can either sense them as digital or as analog, and they're easy to react to. And I've put 5 of them on the front of my robot. I've got one sideways to check if I want to do wall following, and then I've got a center one, and then 2 at 45 degrees. And that gives me a pretty good array of information coming on the front of the robot. As David probably knows, I'm at a point now where I've got more information than I've actually written programs to deal with. So,
how do you think the infrared works versus the LiDAR? I know 7 Protons, I forget his name, is using that 360 LiDAR. I was thinking about using probably the straightforward LiDAR. Do you think the infrared's better or cheaper?
Well, it's a different thing. I think I was trying to describe to Harold sort of this idea of having levels of complexity of sensors. And if you've got a really complicated sensor like a LiDAR, that means your program has to be correspondingly complex. But at the low level of the robot, you really do need to deal with bumpers. And so it's just like on, off, the left and right. And once you're dealing with the low level, you kind of then jump up to maybe, infrared analog, and then jump up to a LiDAR or a camera as a sensor, because that's a very high level sensor. And and as David's been banging on about with me, is I need to focus on just getting the robot running, before I try to jump into something really, really complicated. If the robot can't survive driving around my house, it can't do anything more complicated with a camera. It has to first be able to survive hitting a table, you know?
Right.
So,
my goal is to get it actually moving before I try to get it smarter.
yeah, exactly.
Yeah, and a lot of those things work, right? Oh, go ahead, David. Go ahead.
Those sharp sensors are really clever. What they have, basically, you've got a laser that gives you points. Then parallel to it is a little. It basically works by parallax. There's a little linear sensor in there. So the closer you are to an object, the closer the reflection is to one end of that linear sensor, and the further away. Yes, the one end. The further away you are, the closer it is to the other end. So basically, it just reads across that linear sensor and returns you a distance. Actually, it returns you the inverse of the distance. And there's a problem as you get up close because the curve doesn't look like this. It actually looks like this. But when you're real close, it starts looking further away again. And there's various ways you can ameliorate that. An easy way is just to mount it back from the front of your robot so that you don't ever get any detection that close.
Yeah.
But those are really clever. I will say the downside of those, and it's the same problem that you'll see with the LiDAR, which is that you're really only sensing a single point out there. So that means you can miss a whole lot. If you look at the bumper that Murray was showing us, it's a full coverage bumper. That is, anything that does hit the bumper, the rest of the robot will be cleared. You're okay. So there's nothing that you can run into with that a single point sticking out like that. There's all kinds of possibilities for things above and below that get missed. Chair legs like that. If you're running it around in your house and you have a rocking chair, the rear of those rockers sticking up in the air is just a robot's nightmare. They're hard to see and they poke you right in the eye, you know. So that's the downside of those sensors, is that they miss things. And there are various ways to get around that. You may have seen some of the LiDAR they actually have on a servo so that they're scanning up and down, so you get a little thicker turn of. There are also infrared proximity detectors that have a very wide field of view, maybe 45 degrees or something like that. So instead of a point, you have maybe just 2 of those, or maybe 3 of them. You could cover an entire 90 degrees in front of the robot. Typically, those are just proximity sensors. That is, they're set for a distance. You don't get to know how far away the object is. You only know that I saw one, and therefore it has to be closer than 10 inches. There you go, right there.
That's the little digital ones, and these are what David's talking about. They come in a 5 centimeter, 10 centimeter, and 15 centimeter range, and you get anywhere near them and they just turn on. And they're cheap. They're not very expensive, and they just have 3 pins, so you give it power, and it just has a single pin that goes on or off if you get near it. The 15 centimeter ones work pretty well.
So if I held up a piece of paper, can you see that? I'm going to try to do a drawing. I'm going to try to do a drawing. All right, and what I'm drawing here is a robot. So, can you see my robot?
With the 3 wires.
A left and right field of view. And what you'd like is coverage of everything from, say, 60 degrees off the center around the center, and be able to see left and right. Now, basically, think about that like an infrared bumper.
Yeah.
That is, it's not going to help you with navigation. What it's going to tell you is that you're about to run into something. And in theory, your higher level behaviors are smart enough that they're not going to run you into anything, but they fail sometimes. And when they fail, then that infrared bumper will catch you, but those fail sometimes. And when they fail, then the sensor of last resort, the bumper, saves your robot, saves and protects your robot from damage. And even these little robots can generate a tremendous amount of torque. If you've ever seen one, it's stuck up underneath a railing or something like that and just tear itself apart. Look at Ray grinning. He knows what I'm talking about.
Burn its motors out.
Well, what
typically happens is it starts breaking. You hear breaking and crunching sounds.
Well, one of the things that I've done in my robot, which I haven't actually tested yet, but there's actually a current sensor that measures the amount of current that the batteries are delivering. And so I get an idea of what the robot does under normal stress, and then I put a threshold on that. And that sensor, basically, if it hits the threshold, it means that I'm driving my motors up against the wall or something. And that I've got sort of an emergency flag in my robot that if I hit it, it just stops the robot dead and stops moving because I don't want to burn anything out. And I haven't actually tested that, but basically I've got a current sensor. It's Adafruit YNA 260. It's about $7 or $8, and you just basically run your battery through the thing, and you can get an actual measurement of your current. And that kind of thing isn't necessary for a robot, but one of my principles is that my robot should be able to survive my living room, and if they can't, I don't want it burning any motors out because they're expensive. And
you know what an eagle tree logger is?
Say again?
Eagle tree logger.
No.
This is something every robot builder should have in their kit. You guys go look it up. Eagle tree. I first ran into these on my radio control helicopter. It's an amazing little logger. The thing is about an inch square by half an inch deep. And you plug it, as you say, you plug it into your battery. It also has a whole bunch of external inputs. And then they've got all this software to go with it. So you can graph and keep track of your battery voltage.
Oh, yeah.
Current, and temperature. I put temperature sensors on the motors. And, on the big helicopters, we're running 40 volts at 150 amps, something like that. And so it's real useful to keep track of how much power you're using and in what configuration. But I found that I can post on to the group some of the graphs I have of the actual voltage that's used by mostly my outdoor robot. I've done it. But
I just posted a link to it.
It's incredibly useful. I found them real useful. I have one mounted on each robot, and I've got an extra one that I can move from, on each helicopter. And I've got an extra one I can move from robot to robot. And it generates these just incredibly useful logs.
Cool.
Say again what the name of it is.
I posted a link. Dave, I posted a link on the chat.
Okay.
It's eagle like the bird and tree like the tree.
And that already has a Dean's connector on it, so you're ready to go with most RC batteries.
Now, one thing
and all my stuff uses Dean's connector. You're talking about these, right?
Yeah. The two blades, one's horizontal, one's vertical.
And they're wonderful little connectors. They're spring-loaded. They're great.
I've been using some Traxxas stuff and some of those XT60s and 30s and stuff like that.
Also, the mini beams and stuff. If you're not going for power, the mini beams are real.
Anyway, Dave, that's my linear actuator. It's like an RS 550, DC motor, and I've got I 3D printed the black thing is just like a mount that holds the tube, a certain distance away from the motor, and those are big.
Now, next, Ray's going to jack up your house.
Say that again.
The next thing is Ray is going to jack up your house with that.
Oh yeah. It's pretty strong. I haven't stuck any weights on it to figure out how much it can lift, but I have back-to-back radial bearings in it, because it'll take compression, but it won't take tension. So if you put two back to back, it's kind of like an axial bearing, which also only takes compression. So I welded, these are all nuts that I've welded to a threaded shaft. And there's two back-to-back bearings in here, and the other end is just made in aluminum, basically spacer. So this rod gets pushed out or pulled in to the body of the tube, So that's kind of it. I was thinking of using this one for steering. I'm kind of curious with the. I've got a 5-to-1 ratio on the pulleys, and the rod is a 5/16. Oh wait a minute, no, it's 3/16 threads per inch. So I'm looking up some formulas, but I didn't see any that made sense. It seems forces that you can actually generate are very small. With this thing, if I grab a hold of the rod, I have a hard time pushing or pulling it back. So I'm assuming it's, tens of pounds of force, which maybe enough. And it's fairly fast. It'll do probably about an inch a second. So, push this rod in or out. And it seems like all the linear actuators that that you can just buy, they're either 500 Newton, very, very strong, very powerful, and very slow, or fast but weak. So, and much too small. So it's kind of like, I was actually waiting for this guy to come in. And this is that 380. I think it's kilogram centimeter, that this thing will generate. But that's at 24 volts, and I only have 12, so it's probably going to be half that. But that's something kind of pre-manufactured to do the same thing. It's basically a huge servo. So,
is that timing belt that you're using on your homemade linear actuator?
Yeah. GT2. That's what's used in all the 3D printers. It's like probably the most common one now because of that. But yeah, you can get tooth shear and everything else with timing belts if you snap them too quickly or reverse force on them. Everything can fly apart basically. So
it's great. It's great.
Yeah, so I'll try to do some testing with it. I think I'm going to put an encoder on the motor, so I, and at least one homing switch, so I know, where the thing is to start off with, and then how far out it's actually pushed back or pulled in, and then that way it's less likely to destroy itself or for me to destroy it. So. Anyway.
Cool. While you were doing that, I had shown you guys this little sharp sensor, and I thought I might as well pull out the big one because this is the small sharp sensor, and this is the really, really big one. And this one actually creates a fair bit of heat, and I think it goes 5 meters. And so it gives you an analog distance measurement up to 5 meters. And it takes a fair bit of power. I can't remember how much.
5 meters to feet.
200 milliamps or something like that just to run it. But did someone just have a metric conversion online? In any case,
I didn't realize my mic was on.
In any case, pardon, David?
Do you know what the minimal measurement distance of those are?
Not off the top of my head, but I'll look it up because I know where it is. So I bought it from Adafruit. I mean, it is a sharp sensor, but I think they're pretty. That's where I got it from. Yeah, it's a Sharp 2Y0A710. There's a whole bunch of these things. Different companies sell. I mean, we don't go to Sharp for them. We go to robot companies and other vendors, and they all sell different ones. I think Sharp must sell hundreds of these things, different varieties of them. Sharp.
Yeah, at one point they were going to stop manufacturing.
Here it is. It's $30 US, and if the screen would quit updating. Yeah, 500 centimeters range. It says 100 centimeters is the low end. So basically
Like
1 meter
4
to 5 meter range. So you would use that to augment your closer sensors. But this is an infrared sensor that can go up to 5 meters. So that's quite a lot of light. I mean, it does have really big lenses in the front. So it's got, you know, the ability to pick up. I don't know. I think they're, David, do you remember if they're running at 38K or something? They put out a pulsed 40? Okay. Yeah, so they basically put out a pulsed light and then read just that frequency so they don't get caught by shining lights and stuff.
And I tell you a caveat to watch about those sensors. That 40 kilohertz range shows up on the power rail. If you look at the power, there's abrupt.
I can imagine. That's why this is not on my robot.
Well, for that reason, those Sharp probably need to be isolated on their own power supply, separate from the microprocessor.
Well, these little ones,
yeah, same thing. Look at it on a scope. You'll see these. Like, I don't know if you can see this. This is a homemade night vision scope, which is useful if you want to work with infrared, because you can actually see the infrared signal. And what I can tell you is that those longer range Sharp sensors, not the ones that work out to 18 inches, but the ones that work out further than that, they don't actually project a point. They go through a lens that actually is a holographic lens and makes it project an image. And the image is a little square with an X in the middle of it. Right. And so that square actually gets much larger as you get further away. So it's not like a point, like a laser. And because it's getting larger as it gets further away, that means that you know less and less about what is the actual point that it's returned from. In some ways, it doesn't matter. Another way of describing that is the resolution goes up as you get closer to the robot, which is exactly what you would want. You know, the highest resolution when it's right there in your face.
Well, go ahead.
I'm done.
Well, I was just going to say that one of the reasons I'm not using this is that I've actually already got 2 different kinds of sensors that have a longer range. I've got an ultrasonic sensor that goes out quite a long ways, and I've also got another one of these little breakout garden, the Pimoroni breakout garden sensors, which is about the size of a postage stamp, and it has a LIDAR. It's not a spinning LIDAR, but it's a single point LIDAR that goes out 4 meters and has an accuracy of about an inch. And those actually work really well. And as David says, with an infrared camera, you can see the light that these things are putting out. And in fact, you can buy if you've got a Raspberry Pi, you can go to Pimoroni or Adafruit and buy an infrared camera for it, which is pretty cool. It has an infrared light source, and I've got one of these. And if you see the sort of pinkish image that comes back, it's not black and white, but it's kind of pink and white and black. But you can actually see the lights coming off these sensors with this infrared camera, and so you can actually look at your robot with this camera, and you'll be able to see what it's actually putting out. So this little LIDAR, you can see it pulsing, kind of a light purple light, and you can even see the dot that it makes on the wall with a special camera. So, but the infrared cameras are kind of cool. I mean, you can run around and at night with your robot and scare your cat. I mean, it's great.
And when you look at your robot through an infrared camera, it just lights the whole thing up like a Christmas tree. Every little LED. I don't know if I showed this before. Can I hold this up where you can see it? John, I'm trying to hold this. I can't see it myself. Here's my 2-position bumper like we were describing, and mounted in it, you can see there's a pair of sonar. Can you see there's a pair of, yes, there's a pair of sonar. And then if you look up in under the bumper, you see those little black boxes. It's to deal with exactly that problem Murray was describing, which is that infrared doesn't like to go through the polycarbonate, and you get reflections back off of it. But basically what I've done is I've built shadow boxes and glued them to the bumper, so that separates the IR from the sensors. The sensor's actually in the little box in the IR. There's one on either side. I don't know if you can see that here or not. But where I was going with all that is, I can show it. You can see here mounted over the wheel are 2 of those Sharp IR distance sensors he was just describing. And see, they're looking through the bumper. They're actually looking sideways, and they're actually mounted on 3D mounts so they can look slightly down and sideways. All the rest of the sensors are mounted too along the bumper, but those two, I don't know if you can see this or not. Can you see those?
Yeah.
Yep.
Mounted right over the wheels. Yeah, there's one. That are these proximity detectors down here basically cover an area in front of the robot out to about 12 inches. And they just act like a bumper, as I was describing earlier. The sonar gives you, I got to 32 feet with the sonar. Although that information is really useful. Anybody tells you, oh, my robot can see out to 40 feet, you see, yeah, but what do you do with the information about what's 40 feet away? You know? What I'd rather know is what's 10 inches away, what's a foot away. None of our robots, I suppose if you had a robot that could do high speed, if you could do 30 miles an hour, you probably wouldn't be looking out to 40 feet in order to have enough time to respond and so forth. But ours are like a couple of meters per second or something like that. And there's no need.
Hey, where'd you get your sonar sensors?
These
The big
Those
ones.
are old school ones.
all right. These are such cool sensors. They're great. They can see chain link fences. They can see foliage, which those little ping sensors can't see. These were originally, they started off their life in Polaroid land cameras. They did the automatic focus. When Polaroid went out of business, a company called SenseComp, SENSCOMP, bought all of those, and they may have actually manufactured some as well. But they're a little more complicated to use. They take several signals, but they have a lot of flexibility. And as I said, even on this one, which sits down on the floor, and so therefore you have a limited range because you're sitting so low to the ground. Eventually, you hit the ground and get reflected signals, even if they're angled up, which these are. But even so, they can see out to about 18 feet, which when maneuvering around a building or something like that, that's great. That's just great.
Yeah, and Jack, those things were built, conceived, used in retail, and obsoleted way before you were even born, probably.
Yeah, they're very old. Yeah, those cameras are around, I think, even in like maybe the 70s. I can't remember. 70s or early 80s anyway.
Yeah.
So.
Yeah.
But as I was saying, Doug, a lot of my designs are actually influenced by David's, and so I'm doing very similar thing here. That's that front sensor again, and you can see I've mounted my side sensors here. So I've got one little infrared on the side, and another one on the other side, and that's so I can do wall following. So as I get near a wall, I can tell how far away from it I am. And that's what David's doing, I believe.
Let me
tell you how mine are angled forward.
Yes, don't angle them, have them straight out. They will give you the wrong answer. You need to angle forward.
Mine are angled forward. If you're driving along parallel to the wall and you're looking straight out 90 degrees from the robot, then if you turn toward the wall, that distance will become greater. And if you turn away from the wall, that distance will become greater. So you can't use whether or not the signal coming greater means you're turning toward or away from the wall. But if you angle them forward, when you turn toward the wall, the distance becomes smaller. And if you turn away from the wall, the distance becomes larger. So by angling forward about 45 degrees, you can use the distance itself to tell you whether you're approaching or receding from the wall.
Hey,
Are you telling me I got to go back and rebuild that bumper?
I'm just telling you that I did.
Hey, John's not dead. It's awesome.
Yeah, he's exactly right. On my first wall following robot, I made the mistake, like you have it, straight out, and it gives you absolutely the wrong answer.
Okay. Okay, when I get down in the hardware and I start sanding all that metal down and remounting, it was okay.
Well, let me add then, if you're going to go to all that trouble, it's also helpful to have the mounted point angled slightly down.
Okay.
that way, well, there's a number of problems that fixes it.
Okay. Well, I'm glad to get the advice. Believe me.
Yeah, that's funny that you say that. I actually did that and kind of gave up on it because it's ambiguous. You don't know you don't know which way to go, and I used some other technique or some other method to figure out where I was. But I know the LiDAR lights. It's a single point LiDAR. One of them will go 40 meters. And it works great outdoors. So if you're looking for those kinds of, maybe distance off a building or something, that would be great for that. 40 minutes, over 120 feet. So it's pretty good distance.
Yeah.
I can tell you a sense in which that would be very valuable. On the JBot outdoor robot, it has an array of sonar that cover about 60 degrees. And that works, 99% of the time, right? But when I used to run that around over at Fair Park, there are a couple of buildings over there that are glass buildings. And what happens is a real highly reflective surface like that is you can get the radar at a certain angle where instead of getting a reflection back, it just reflects away. If you're at a steeper angle, you get a reflection. If you get a shallower angle, you get a reflection. But at a certain angle, it reflects away. So what the robot sees is when I get to a certain angle, there's not a wall there anymore. So I can just go that direction, and it'll go over until it gets almost to the wall, and it'll go, my God, where did this come from? And turn away from the wall. So if you had those LiDAR lights arranged, let's say, at another 15 degrees out, you would have to say, I have to have agreement between these two sensors. And therefore, when you rotate it through the angle, you could use the LiDAR to say, no, there's a building there, don't go that way. Even though the sonar, I don't see anything. It's an odd case where as you get closer and closer to a wall, you run into that more and more frequently. So that if you're right up next to a wall and you do a scan past it, as you do that scan, somewhere along in about like right there, that bounces away and maybe hits something over there and comes back. So instead of saying that wall is 6 feet away, it says that wall is 30 feet away. But he still thinks it's right there. In small enclosed spaces, sonar can do some funny things because of the way it bounces around. And what you have going for you is that those are intermittent. That is, the real signal will be constant as you go through a rotation. But something that says it's 6 feet away, it's 7 feet away, it's 40 feet away, it's 8 feet away, they're transient. And so you can write your software to ignore those transients. But it would be better to have another sensor in parallel to that one to tell you, no, that's wrong.
Like what Mary earlier.
Its spot wouldn't be a problem.
And in fact, that's actually, you guys have talked about this before, and like this is this little LiDAR sensor I was telling you about, the size of a postage stamp, and this has got a 4-meter range. And actually, I've got this on the front of my robot on a little servo, so it can actually rotate. And I'm doubling that with a servo-mounted ultrasonic, so I can actually do a scan over an area and get the comparison between the ultrasonic and the LiDAR, and therefore get some idea of which ones, like you won't see, for example, a chrome chair leg very easily because it doesn't really reflect anything at all. So there's certain things in your environment you might have to simply remove from your environment. Oh my God, I said that, but it's bumper, yeah. But I take what David's saying is quite cool. Even when I'm scanning with my LiDAR, what I'm doing is actually taking 3 measurements at a time. And then if one of them shows up to be way out, I throw out the whole measurement and try again. So basically, I do see a lot of, even with these, which are pretty accurate, like, to the inch kind of thing, I do see spurious measurements now and then. And so if I do 3 measurements and they don't seem to agree with each other, I'll just stop the thing on the servo at that angle and try again until I get something that seems, consistent.
That's what I was percolating in my head. I didn't say a whole lot about. I've got, this is one of the parts of the robot I'm going to put on there, right? Got the swivel and the thing going on there, right? So I can 3D print something, slot in here. I put my camera on one side and here's and Murray, you're fancy dancy LiDAR on the other one, and I can see what I'm pointing at, and if it's over 12 feet away, I don't care because my Nerf gun's not going that far anyway, right? And so, or something along those lines. Yeah, I'm talking pie in the sky, right? But that's kind of the idea I was thinking at some point for that gooseneck that was standing up. So one it could look and see how close it was, and hopefully between the video, it's kind of poor man's connect maybe. Between the video and a little bit of LiDAR that's going on between the two, maybe you can make sense of the world and do something smart eventually. You know, I don't know. Maybe. Anyway, thoughts?
Harold, the way I'm looking at it is that I'm trying to figure out, I mean, I haven't got this far. This is David banging on my door again about actually getting my robot running. But the purpose of having these longer range sensors, in my mind at least, until I get to the point where I'm actually proving this, is to find doorways. That my house isn't that big. And if I'm in a room and I'm scanning, and I have done this much, is that the robot scans back and forth. And if I open my study door, all of a sudden it goes beyond range because it's going into the hallway. The robot would therefore know where the doorway is, which is kind of one of the things I'm trying to find out. And so if I'm trying to get in and out of a room, I can scan and then find, it's pretty much like, 2 meters, and all of a sudden it's 4 meters. Like, okay, that's probably where the door is. So that's the kind of thing. I'm not doing outdoor robots, so it's pretty much constrained by what I know that my lounge and my kitchen looks like. And so these long range sensors aren't that necessary. David's robots are going up in the mountains. He goes long distances, but for mine, the going past about a couple feet in range isn't that valuable, apart from looking for doorways.
Yeah, I was going to say the rotating LiDARs like the ones Jack's using, if the angle is too shallow, you won't get any readings at all. But those LiDARs, they typically have other indications as to whether that reading was a valid reading or not. So you can just read that, if you don't get an actual reading, and then say, okay, I guess that was deemed invalid, so you have to ignore it because it can't, physically can't produce a reading or result. So, but
Ray, does it give you some kind of confidence value or something like that to tell you how much you trust this reading?
I think it does. Yeah. I think there's also, there's at least a single bit in there that says it's, a valid or invalid reading. And but yeah, along with the reading, you get like a kind of a confidence. I don't know, maybe it's the first AI. It's not black and white. It's 90% sure that that's a good reading. So.
Jack, do you see that when you played with that? Do you see a place where the data drops out, or where you don't have
Well, mine doesn't have the confidence rating, but I haven't had a ton of problems with bad ratings. I'm not sure if I put in some sort of program. I don't remember what I programmed it anymore, but I haven't had any problems.
Yeah. Yeah, the Nito LiDARs had that. So, or the LiDARs from Nito vacuum cleaner. Kind of the ones that what's his name used to sell? James. Yep. Anyway.
Okay, well, I'm back now. I don't know what happened. I hit the wrong switch or something. So.
Oh yeah.
I have a question.
My poor computer got shorted out, I think. In other words, I had the cable into the robot, and I must have turned on the robot, so it was feeding the 9 volts or whatever into the USB port thing, and decided the computer said, so it basically, shut down for it until it cooled off.
Ooh.
Yeah, it's not fun. So yes, remember to unplug the thing when you turn it on. So I was trying to now do what I was going to do without it being plugged in, if you'll notice. But anyway, I was going to show I forget your name, but anyway, Harold, I think, yes, Harold, that you don't have to have reels. You can have feet. So this is when I printed out that whenever.
This is
and the key is this read. Yeah, and this week I was going to program, I didn't get around to. I was hunting down the code I had from whenever, and guess what? I couldn't find it. I'm going to have to start from scratch. But anyways, so right now I don't know what it'll do. Yeah, it'll move a little bit of that type thing. But yeah, it'll move a little left. But eventually it'll walk. So maybe next week I'll find the code and put it all together. But yeah,
And I think we should probably point out that we've given John a requirement on his robot that it can scratch its bum.
yes. I've already told it can't scratch the butt because you can see why Kendall is scratch his head.
Okay.
So it can do its number.
Scratching of any kind is okay.
The head of the butt pretty much just the same part. I don't know, you know.
Well, as I say, it can beat the head when it doesn't, know where it's going. And
I have a question for Dave Ackley. Dave, are you awake?
Yeah. Yeah.
Well, Ron Grant told me like last year that you had a setup that you could do CNC milling of circuit boards. Is that a true statement?
That's a true statement.
But
Well, let's put it this way. Since it's been probably now 2 years since I actually did that, I would probably take about a month to recreate how to actually do that. But
well, it wouldn't be that long.
Yeah. But actually, I used what is it, Dip Trace, I think it is, for the board design. And there's a program called, oh, my brain is gone. Flat Cam, I think it's called.
That sounds right. I'm thinking, yeah.
Set of G codes on the engraver.
Yep. You even got probing working, right? So you can figure out how work.
Right. And the I forget what the name of the thing is now, but yeah, it has a built-in profiler for the height, because as you're trying to drill the thing or mill the thing, if you're off a few thousandths, then you'll either not cut or you'll cut too deep, and so it'll actually profile the circuit board.
You mean to know how thick the circuit board is?
No. What it has is that it has a you hook it up, you connect the circuit board itself, say to ground, and then you take the mill and you use it as a probe, and it probes for the height of it and actually contours the surface. And then you say, okay, mill three mills into that surface.
Oh, that's so cool.
Yeah, because reality is a flat surface not that flat, especially on a bed. And when you get into thin bores, you can go through, and that's why you tend to have a feather bore underneath there for that reason. But there's software out there now that will allow it to basically flatten it, so it literally goes through the code and adds variables to it in the spots to make it virtual flat.
Right.
You're telling me flat is not flat?
Yep.
No.
Oh, my faith in the world has been destroyed.
See that right there. There's my feasibility board that I did with it.
Yeah.
Oh.
Because I've got, I do a lot of 3D printing, and I'll tell you, when I get down to the measuring things, that kind of stuff, you think a piece of glass will be flat. No, you'd think it would be. It's not even close.
Yeah.
Not close. I got a piece of glass over here. You think it's flat. If you go from one corner to the other, you're probably maybe 50 mics out sometimes. Not quite a full tenth of a millimeter, but enough to throw you off, especially doing what you're doing with the PC board cutting and all that sort of stuff.
Oh yeah.
So Dave, did you program?
That's my feasibility demo.
Did your program also drill the hole?
Yes.
So it both etches the copper and it fills the hole?
Oh, yes, absolutely. And cuts the profile, cuts the board out.
Okay, I'll tell you that, be careful what you say here. The reason I'm asking all this is because the reason Ron told me was because he said he had sent you the Eagle files from one of my boards for you to see if you could make it. Do you remember?
No, I don't think so. Well, the other is that it's good for making single-sided boards, but trying to do two-sided boards, it's feasible, but it's a bitch.
Why?
Well, you've got to make sure it registers properly and make sure you've got the right mirroring and all that sort of stuff.
It's an alignment issue. And basically what you would do there is you have a post or something to align it with.
Yeah.
You have to have a dig, basically.
It's doable, but it's, you know, like so many things that you double the number of sides and you go up in complexity exponentially.
But you have to realize he did it on a $200 CNC China thing. At least it was about $200. So you can get more fancy CNC machines that are more accurate.
Oh, yeah.
It was really amazing how accurate it was.
I decided to go cheap and dirty. But it will do it.
Very cool. Well, that's a robot. Doesn't that count as a robot?
Yeah.
Oh, yeah. Programmed, and hopefully it follows its instructions.
But
yeah. I'll go drag it out. I have one.
This is that's what it looks like. There's my ruler. You can see it's about an inch square. As I recall, I could do about 2 mil line widths and 2 mil spaces. I'm sorry, 12 mil wide lines with 12 mil spaces, 25 mils between them. Between centers.
Very cool. Well, gentlemen, are we done?
I think we are.
I think so.
I had another question.
Oh,
Programming. Everybody program Python on their Raspberries or other choices?
Nope.
things.
I'm a Windows IoT core person. Some people do other stuff. So
You got Windows IoT working on the Pi?
yeah, the Pi
It really depends on. Well, it really depends on what your processor is. If you've got an ARM processor, you might be programming an assembly language, or you could be programming in a graphical language using a UI. You can program in Python, Circuit Python, which is a subset of Python. You can be programming in C# or C++ if you're on an Arduino. It's pretty much the sky's the limit. You can. It's if you've got a Raspberry Pi, you've got all of them as.
I got a Sony Surprise. I don't know if you've seen those guys, Presence or whatever it is. I think that's how you say it. The thing's about 1.5 years, 2 years old, and the only interface you have is C++ if you want to do real time. But if you want to do high level, it's just old school C. There's no anything other else than that. So it depends on the piece of hardware you pick up.
Yeah, the thing that David Anderson, I've hooked him on is ST Micro. I don't know if you can see that there. That processor, well, for some reason, I'm not showing up. But anyhow, that processor is what's called a blue pill. And it goes for about $1.75, I think it is, from China. And it's about a 4x of an Arduino. 4 times faster, 4 times as much memory. Word size is 32 bits instead of 8, and etc.
And if you want to go a bit crazier, what I have in my hand here is something called a Latte Panda.
Yeah.
It's SoC. It's a complete system on a chip. It's a complete Windows. I got Windows Pro running on it right now, full bore with IDE and the whole work. And I say the Windows graphical, all that running on this thing, and it's going to go on that robot I was just showing off there. And it supports all the stuff you'd ever care to support, especially being a VB guy, right? It does all the stuff you're used to doing and does it on that board.
Yeah, and here's a cool AI board here. This runs Ubuntu, Linux. And
Yeah. Of course, Murray shows up. You ain't got nothing here. Let me show you something.
I can't recommend these though. This one's almost bricked. I can't. It's the worst purchase I've made in years. But this, for example, is a little tiny programmer, a little processor that runs entirely in JavaScript. So I guess, Doug, the point is that you can pretty much choose the hardware you want and choose almost any language you want, depending on what you want to do.
Yeah.
Oh, he's got one of those.
That's an ARM processor there.
Yep.
Right.
Yeah. ST.
Well, he's right. Basically, whatever language you're used to. So if you like Python, I would say go with Python. And then after that, the question of what machine can run Python.
Yeah.
So rather you run it and wherever.
I'm old, and I programmed VB since I was young. I've never done Python. I know that Mono runs on the Pi and allows you to run VB. And I heard that Windows IoT could be on the Pi.
Well, it depends on the Pi. We can have a big old long discussion on that. If you want to, Doug, chat me up somewhere or something along the ways. You should have if you don't have my email address, I'll put it in the chat. And
I'm pretty sure I can find you. I've mentioned you before.
John, did you say you were
Yeah, I was going to show you something. Before that, though, Harold, if you want to discuss this on Saturday, we're needing somebody to discuss. That sounds like a good subject.
Well, it is. I mean, I kind of can. I don't know. I'm not really prepped for doing all that. I can only tell you because I'm a bit dejected with it, honestly, for a couple of reasons. Like the Pi 3 is great. And it's supported under a version of Windows 10 IoT, and will be for the next 8 years, I think, something along those lines. But the Pi 4, which is what I want to use, it's not really supported. I mean, there's a skunkworks thing out there, but the onboard Bluetooth, the onboard Wi-Fi doesn't work. So you got to plug it in hardwired. Don't put its own dongle in there to do other things with it. It's simply because the Microsoft. I guess you guys were on a lot of you were on when we had Lou on here. He explained it much better than the way I would explain it. I would explain it more. They just dumped us in the trash. But no, what really happened was they're looking more of an industrial. They're looking more to go what industry is using to do what they do on a daily basis. And for the most part, as fun as Pis are, I have to agree with them. If I'm doing something in production, I'm not making the Pi the heart of what I'm doing for production. There's a whole bunch of reasons why, but at least of which is legal. You know, they're not meant to do that. There's licensing for the HDMI, and there's all these other kind of things you need to worry about, and EMF and getting it UL certified, all those kinds of things. This Pi is not it. And so they're looking at going to things where they can put stuff on hardware that manufacturing and all these other places can just use it and not have to worry about those sorts of things. And so doing this Pi here, doing the Pi 4 is not on their the return on investment on that is low. It's not going to happen.
So you're saying basically Raspberry Pi computer.
And if you want to get hacked
on with Raspberry, would probably be the way to go then.
Yeah, if you want to get hacky with it, you can get Windows 10 for ARM and get modify the bootloader on your Pi, and you can put Raspberry Pi. You can put Windows 10 directly on your Raspberry Pi, but there's people out there doing it. They're hacking on it, but I think that's not the best way to go on that one. To be honest.
I run Fortran on my Raspberry Pi, and I program it all in Latin. John,
I would have better.
There you go.
John, did you say that you program in C? Is that one of the languages you mentioned?
Are you talking to me now?
Yes.
I'm been VB my whole life. I can do C# if I have to, but I'm a VB guy. I think in VB, and I'm thinking, do I need to learn Python? I can.
It's not that hard. I was going to say I at least know 4 or 5 languages, even Fortran, COBOL, and most low languages. So
The basics of Python wouldn't hurt me at all. It's the connectivity part, like how do I call a web service and how do I do the high level stuff.
Well, I think
Well, a huge advantage for Python is that there's so many libraries available that will solve probably any problem that you have. You can go out and find a free library that would do it. And if you're comfortable with Visual Basic, you know, good Lord, all Visual languages are the same.
I know.
a for loop is a for loop. It's a matter of simple.
All instances are the same, you know.
Right.
I can almost guarantee you that the language that you won't be using, there's a language you probably won't be using. If you're going to use it, you're not going to use much of it, and that's going to be assembly. Everything else is just open. Everything else is just open.
Doug, the way I looked at it is when I jumped into robotics, one of my goals was actually to learn Python. But in the world of robotics, of small robots, if you're not an assembly language, you kind of got 2 camps. There's the Raspberry Pi camp and the Arduino camp. Arduinos are in C++, and Raspberry Pis are kind of in anything. But most of the sensors that you see out there that have libraries, which you want to take advantage of, the libraries will be either Arduino libraries in C++, or they'll be Python libraries. And unless you want to do both, you got to kind of make a choice. If you've already got a Raspberry Pi, like I said, most of the stuff I'm using is either from Adafruit or from Pimoroni, and those vendors are giving me libraries in Python. And I wanted to learn Python anyway. But if you go Arduino, which there's thousands of things in Arduino as well, you'll get lots of support in C++. And it's really kind of one or the other unless you want to do assembly language. That's what most of the stuff in robotics and small robots is right now.
Well, I'm probably gonna jump into Python now. I had looked at that Panda that Harold had. It was pricey, which is why I didn't jump for it right away. But it could do Windows.
It does do Windows. There is no doubt about it. And it's a full-on install, so you want to run .NET and the latest whatever. In fact, that's what I plan on powering all my machine learning stuff that hopefully on my robot, a camera will be looking through and doing, right? But that's kind of the brains. There's also an Arduino baked into the thing as well, so you can tell the Arduino to go do various things on it. But the Windows itself is probably much the brain. It'll probably do things like, I see it, things like it'll send a message over a bus that says, hey, I want to move forward 27 feet or 27 millimeters or something. And then something else on the robot will pick up that message and actually go do that. Windows is not going to be real time, and these guys will tell you this is a really real time world. And if you miss a thing going high for a few milliseconds, now you just run your robot off a cliff or wherever it is. It doesn't take very long at all to get into trouble. Yeah, you want to still separate all that stuff up. You want the real time stuff, which is Arduino based sorts of things that are real fast. You know, something fast that the operating system doesn't get in the way to do all of that stuff. And the smarts of it, you can do whatever you want to with it, whatever you feel happy with.
We'll follow up on that just by saying that folks who are running a Raspberry Pi on their robot also have a second processor to actually handle the robot process. So the Raspberry Pi might be or Windows or whatever, but it's probably not real. And so there's another board with a processor on it that's charged with reading encoders, sensors, and calculate state and that sort of stuff. And one of the arguments that we've had before, I shouldn't say argument, one of the discussions we've had before is, well, if you have to have a separate processor to do all of that, then why can't you just do everything on that processor? Why do you need the Raspberry Pi at all? And I think that one of the outcomes of that discussion is that the Pi gives you Ireland, for example, gives you a TCP/IP stack that you're not going to get on an embedded operator. So if you want to talk over a network and so forth, you're really not going to be better than it's possible, but it's not going to be fun. And also it gives you access to a whole lot of the artificial intelligence stuff, the neural networks and things like that you're also not going to run. on Arduino. Nonetheless, your robot's probably going to have a separate microprocessor that can handle all the real-time stuff, and most of your code will be developed on that process for most of the work. And if you're trying to decide what processor,
Yeah, this is a
I would highly recommend
robot platform.
Yep.
So
Anyway.
David keeps holding up that, and I can't read what it is.
Oh,
It's an
the company is ST Micros, and that's a Nucleo, N-U-C-L-E-O board. It's actually an STM F32 446 or something like that. They make a whole bunch of them. David turned me on to that one because I was complaining that I didn't have enough serial ports on one. They make a whole bunch of them. They run about $10. It's a full 32-bit processor, runs 100 megahertz, and it's just wonderful.
what language are you programming in?
Memory and
I program in C, Dave, and I've also done a little assembly on ARM. I know that makes me an oddity, but for those of you who are familiar with assembly code, the ARM instruction set is really cool.
That's cool.
It is really neat. I mean, it's a pretty different way of thinking. For example, there's no return stack. And anyway, I could go on in detail about that. I've written a little ARM assembly. But you're going to have to end up with something like, the reason I held that up is that board has the same interface on it that the Arduino sees, so it can use all the Arduino add-on cards. But it's this much more powerful processor than the Arduino. And especially if you're used to, really get high performance out of a little 8-bit processor requires superhuman effort. It's possible, but it's not trivial.
yeah, it's a lot easier to use a processor like the one I gave you than to try to struggle with a Arduino.
Yeah.
And it's got half a meg of hard program memory and a quarter of a meg of
And it's got
RAM.
and it's got built-in DNA, and there's all kinds of stuff built into the hardware. Almost all the drivers that I've written for it, you just once the driver's completed, you just set it off and run, and the drivers run in hardware in the background. You just read and write to them.
Yeah, Murray, I hear good things about those teensies, by the way. Really good things about those teensies.
Well, I just posted a link to what's called a Teensy, which is an Arduino compatible that's actually really high performance. They're running, like an Arduino typically runs like 12 or 16 megahertz. These things run well over 100 megahertz. I can't remember. The 4.1 is the latest one.
And
These aren't very expensive. They are like an Arduino, and they run really, really fast.
And go into the 32-bit instruction set, changes the way you can do things because it means most memory operations are atomic, and therefore you don't have to worry about interrupts. When you write a 32-bit integer or float, you're not going to be interrupted in the middle of that write. So there's a whole bunch of other reasons. It's a very cool project.
Now,
Yeah.
I can see that hardware-wise, I have a major learning curve ahead of me. And then my software-wise, I still have a lot of high-level AI work ahead of me. So I don't expect to have one this year.
Isn't that great?
How complex you really want to be. But you can start off relatively small and simple with one chip, and then you'll eventually probably wind up with two because you'll have one to work with interrupts, whatnot, and one to do the high-level processing. As Ray's showing us something. So Ray, why are you trying to
This is a Raspberry Pi with a board that Polulu makes. It actually has one of the is it at mount 32 board on it, and so the that actually does. There's two motor drivers on this little board. It'll, I can read two quadrature encoders. It's got a DC-DC power supply on the board for itself and for the Raspberry Pi. And the Pi is actually, this was a donkey car platform. So it's basically a kind of an AI setup that you can train to do, have a self-driving platform. And so you create a model and actually process the model on your laptop, and then download it back to this thing. And after you train it, you set it down, it'll actually drive the course that you've trained it to drive. But that's an example of kind of the Raspberry Pi doing very high level stuff, processing snapshots from the camera, but the other board doing pretty much all the low level stuff, PID loops for motor control and reading encoders and those kinds of things, because those things have to be done real time.
Ray, how does the Raspberry Pi talk to that daughter board?
It's over I2C. It even has level shifters on it, because the 32U4 runs in 5 volts and the Pi is 3.3. So
yeah, there's a company in England called Fortronics with a number 4 Tronics, and they put out a bunch of different boards. They've got one that gives you servo control and an ultrasonic on the same board. I'm using their motor controller called a Thunderborg, and that gives me an I2C control over 2 motors.
Right.
Put it this way, there's lots of boards out there that give you kind of this combination that David's talking about, which is that you could have a Raspberry Pi for sort of your high-level programming, and then some kind of lower-level processor, either a customized processor that handles motors for you, or like in my case, I've got a little processor like this called an Itsy Bitsy, which is an Arduino again, that gives me all the inputs from my bumpers. But it's this combination of low and high. And in fact, there's even an Arduino here called a Yun that has a combination of a Linux processor and an Arduino on the same board. And this is kind of getting back to that same issue of, like, you kind of want to have high-level programming if that's what you're going for. If you really want to get into like AI or anything like that, you want to have a platform that you can actually program in a high-level language like Java or Python or something, which is object-oriented. But you also want to have a processor on board, something small like that, to handle your sensing, because these things are high performance. Like a Teensy is extremely fast, and it can then communicate over I2C, this little 2-wire bus, to give you your data already all chopped and ready to go at your high level. And there are lots of robots out there that do this for you if you want to buy them already put together. Or if you want to build your own, that's a different thing. And a lot of us are trying to build our own. That's why these discussions come up.
Yeah. What I use as an example is imagine you got a drone that's flying in the air, and you got a Raspberry Pi going on there, or some other real smart thing that's running an operating system. So it writes something to the disk, it's got garbage collection, it's got all those crazy things that are station keeping things to keep the operating system going on the Raspberry Pi, and you get a gust of wind come along right in the middle of a garbage collection. It's not going to know anything happened. So that's why you want that Arduino that does nothing but, hey, keep me at this position, and and it's really good at doing that. And you can tell it what position to get into and all those sorts of things. Just station keep me here, and all the gust of wind, so it'll correct itself and that kind of stuff. And the Pi doesn't need to know anything about it. Or the very smart, slow operating system based thing versus the microcontroller based thing. The micro processor thing just doesn't need to know. I mean, he'll find out afterwards. Oh, something happened. Where am I now? But to correct the autocorrect and all that needs to be on that microcontroller.
In a nutshell, think of it when you walk. You don't really think about walking. You say, I want to go to the tree or wherever. Just do it, because so constantly your mind's processing, the muscles are doing their thing. So the same basic concept of that. In the meantime, I did dig out. So here's the real PC board CNC that Dave was talking about. I don't know if you can see it. So yeah, I haven't touched mine in a year or two either. But this is a $200 cheap China, roughly. So
wow.
It'll do about a 4x5 board.
Yeah, basically. It's a small one. But yeah.
To have 4x5 boards, they need a
Yeah, so I was thinking that I would need multiple processors, and it sounds like I was wondering how they would talk, and it sounds like this I2C, how they communicate to each other.
Yes.
Yeah, it's one way. I could be in the
Video protocol. So it's very much like talking over a serial port. The difference is that you have a clock. So the clock is provided by the master, and so you can get real high speed, very robust communication. But basically, the two wires is the clock and a data line, and you tell the slave whether you're going to read it or write it, and then you clock the data in and out. It's very high speed, and you can have multiple devices on the same bus. But basically, it's like talking to the serial.
Cool.
And if you're using a Python library or an Arduino library that supports the device you purchase, like one of these little sensors, you don't have to actually do the work of communicating. It does the communication for you. So you're just communicating across the I2C bus, but you're dealing with it at a program level where you just ask the device, and all that happens behind the scenes. So you don't have to. You're not running your own serial port.
They do something.
The library give you that support.
I think they do something a little bit different, but all those massive LED signs that are showing all these things in these RGB colors and all those kinds of things. Basically, it's a big old I2C bus. I'm running around all that stuff with sections of those things, putting those things out. That's all they are in the backside of it. Kind of funny. That protocol was developed in the 90s, or either the beginning of the 90s or the end of the 90s, to deal with some kind of Panasonic smart TV stereo thing, if I remember correctly.
I think it was back in '66 or so.
It might have been sooner.
Been around for about a century.
The first time I became aware of any of that, or the oldest I'm aware of any of that, was putting it into stereo equipment and big screen TVs so they can communicate. That's where I came to be realized that this thing is.
Dave, did I2C come from CI?
No, it came from Philips.
From Philips.
Yep.
Yep.
Doug, go ahead. Sorry.
It's chip to chip. It's a protocol that was originally designed to allow multiple intelligent devices that were just a few inches away from each other on the same circuit board to talk to each other, rather than having to use a full parallel bus to talk to each other. A lot of people have grabbed onto it, and robot people have grabbed onto it big time.
Yep. Well, Doug, I was going to mention that we got a local girl, a 10-year-old girl, and I helped her dad and her and her younger sister actually put the robot together. And the company's called Waveshare, and they have what's called an Alphabot 2. I posted a link to it. They put out 3 different types of robots. One that uses a microbit, which is a little BBC, British Broadcasting Corporation computer, a little tiny board for kids mostly. They have an Arduino one, and they have a Raspberry Pi one. And the link I posted is the Raspberry Pi one. It actually comes with an AI camera on a swivel mount on top of it. And without the Raspberry Pi, it's about $150. But basically, it gives you a nice little robot platform with a Raspberry Pi or an Arduino or a microbit. And if you go to the Raspberry Pi ones, you can get the camera already mounted on the top. And this is just one of many robots like this. But you don't have to get into the complexity that we're talking about if you just want to get going. You could buy yourself a kit robot, put it together with a camera or without a camera, and get yourself started without hitting some giant wall right at the beginning. We're kind of talking about things that aren't necessary at the beginning. That's
true. It might be an advantage to get something actually rolling across the floor before I try to get my main robot rolling across the floor.
And you do a lot of learning then. You could learn how to program in the language you choose a platform, get yourself up to speed, and get some skills before you jump into the one that can walk around and shake hands and make you that mint julep.
Yeah.
There you go.
Okay,
Yeah,
man,
I think
julep, I think I'm going to be out of here, guys. Mint julep came out. It's, just saying.
Yeah, I got to get back to work.
Okay.
Okay, well, thanks a lot for the help, guys. I'll see you next week.
Yeah,
Yeah.
more.
I agree with them that I would start small, do a basic. Main thing is figure out which language you really want to start off with. And basically, there's the 2 boards to work with. So you can pick one, and then you can expand from that. But, start with the basic stuff, and what basic language you know. So, you know,
The thing I would say is I don't remember the one. Doug Faraday would tell you which one it is, but for about $25, you can get a full robot that's got everything ready to go and to put together. That's Arduino based, and it's ready to go.
yeah.
Yeah.
Maybe by next week we'll figure out which one it was, because somewhere I think I remember the name, but I'll have to look.
Yeah, exactly.
But last year he did. In fact, he was going to have a class on it, so we may take care of the time. In the meantime, okay. In the meantime, I was going to say we can look it up on our club website.
Yeah.
It may be there, so you might look at the club website to see. I'm thinking it's there, that the robot that we're describing, for around $30, give or take.
Under $30.
Yeah.
Yeah. So I would start with something like that. That gives you your basis, and then from there you can, you know, expand to. I don't know if, you know, like this was 3D printed, to give you an example, and it has an Andrea board with an H-bridge type board on top. So, you know, this is an example of a relatively cheap, you know, about $40, give or take, parts type robot, and that would give you a basic. But it sounds like you already has a Raspberry, so I would say, you know, if you have your Raspberry board, I would lean toward that due to that fact.
Well, I'm not against exploring other boards. I mean, I've got this Arduino here that's probably out of service now. It's been replaced, and I've got a couple of Raspberries. I'm willing to get some Arduinos. Arduinos, to me, are lower power, so that it doesn't take as much battery, and that's a good thing.
Well, they have a little less power, less memory initially, but they, you know, they were meant where the Raspberries was, you know, the last couple of years created, so that's why there's a difference. It depends on how much power you want.
But as Dave was saying, there's other options too besides
there's at least 8 or 9. In fact, in the One Make magazine last year, I think it was last year, they had a whole article about the different boards that were out there and their benefits and pluses and minuses.
Right.
And each board has pluses and minuses.
Yeah, the advantage of an Arduino, for example, is the ecosystem that's out there for supporting it.
Right.
Yeah, there are
Some of
tons
the
of
advantages of the big names. So I'm probably going to just buy that wave share that Murray was talking about, and that'll get me something to play with, and it's also could be an Arduino so that I can practice on that.
Right.
And then my Raspberry Pi that I can practice about my higher level control.
Effectively, that's what Carl did. He for 2 years basically built a virtual robot, and then after 2 years he got a base like $70 or $80 Powerloo robot, and then from there he expanded it. So that's sort of the path he went.
Right.
So that's why I was saying something along that line is probably the best bet.
Right.
Yeah, if you're interested in OpenCV or Open Computer Vision or anything with AI or, you know, learning at the edge and that kind of stuff, all of these are Python based.
Right. That's why I was saying Python.
That's what I was thinking. I was going to have to learn Python. I can do it. I can do it.
It's not that hard. If you know, in my case, as I said, I know several languages. So think of Pascal, in other words, it's pointers and that are you are into red base. So
yeah, it looks like a hard language. I would just the higher level aspects of it, such as how do you make a web server call and stuff. I've seen examples, but it's something you can certainly Google and figure out the pieces you need. So that's probably what I'm going to go with.
Yeah.
So with that, I guess it's about time. I don't know if y'all are finished or went to until next week.
Yeah.
So Dave Ackley, are you part of it?
Here.
Okay.
I'm going to be gone. Thanks a bunch, guys.
Okay. Until next week. Take care. Bye for now.